First, the probabilistic reasoning in reasoning under the uncertainty. What is the probabilistic reasoning? It involves the representing the knowledge using probability theory. You all must know what is the probability theory in the mathematics, to basically analyzing the all possibilities, right? Or checking the all possibilities of a data. So the probabilistic reasoning involves representing the knowledge using probability theory to manage the uncertainty. अगर ये है तो ये हो सकता है, ऐसे भी हो सकता है, this outcome can also become, right? So this approach we widely used in the AI system for the tasks such as the diagnosis, because in the diagnosis of a particular disease, number of possibilities can be there. Predictions, right? For predicting a outcome, for predictive analytics and the decision making under uncertainty. For that, we are talking about here the Bayesian network. So what is a Bayesian network? Is basically a graphical model which is used for representing and reasoning about the probabilistic relationships among the various variables, right? And we use the Bayesian theorem here to update the probabilities as a new evidence becomes available. So basically, what we are talking about here in a probabilistic reasoning, we are talking about there, we are talking about the system should allow and process the truth values rather than only the true or a false, right? So number of techniques we use here, we use the probability theory, we use the random variables, we use the Bayesian networks also. So how it works now? What is the Bayesian network? As we have talked about, Bayesian network is, or Bayesian networks are the graphical models. Like here we are representing the probabilistic relationships among the variables by representing that relationships in form of a graph. So Bayesian networks are the graphical models that represent the probabilistic relationship among a set of variables. Each node in the Bayesian networks represent a variable, and the edge represent here the conditional dependencies. And the Bayesian network allow for the efficient computation of the posterior probabilities given the observed evidence. Like how we can say here this, and what do you understand by the conditional dependencies, the edge and the variable? Remember, we have also talked about the semantic networks, right? We have talked about the semantic networks, where we have talked about the relationship representing the relationship between the various concepts, right? So here also we are talking about the relationship between the various, or the conditional relationship or the dependencies between the various variables here. So a Bayesian network, here we are taking an example of a medical system, or the medical diagnosis system. We are saying that a Bayesian network for a medical diagnosis system might include the nodes for the symptoms. We have talked about this, the fever or a cough, and the disease can be a flu or the pneumonia also, with the edges indicating the probabilistic dependencies between them. Right? Another method, or simply here we are talking about the AI system should use, or when the AI system deals with the uncertainty, it deals it by using the various models and the methods that assign the probabilities to different outcomes. Here we are also talking about the AI system use a combination of somewhere it uses the combination of a probabilistic reasoning, simulation also, the learning techniques also, and the various expert knowledge to handle the uncertainty also. So now another matter here, we are talking about how to handle the uncertainty, right? We are talking about the various methods that involve in the, or representing a knowledge in the uncertain domain in the AI. So another method here we are talking about, what another model we are talking about? We are talking about the hidden Markov model. Are they used to model time series? When we need to model the time series data where the system being modeled is assumed to be a Markov process with the hidden states, and hidden Markov model are widely used in the speech recognitions, in the bioinformatics and the other sequential data applications too. Example is here in a speech recognition, the observed sound waves are modeled as emissions from hidden phonetic states, allowing the system to decode the spoken languages here. Another model here or the framework we are talking about in the representing a knowledge under uncertainty is the Markov decision processes. What is the Markov decision processes? To provide a framework for modeling a decision making in the environment with the stochastic dynamics, right? So what do you understand by this? We have talked about the different situations or the different uh, uncertainties. Markov decision processes consist of a states, the actions, the transition probabilities, and the rewards also, enabling the computational of the optimal policies for the decision making. So here we are talking about the optimal solution also. So here an outcome robot, what is the application here or where we use or what is the application of a Markov decision process here? We are talking about an autonomous robot navigating a grid world can use an Markov decision process to determine the optimal path to its destination while accounting for uncertain movements and the rewards also. So here we are talking about different models here. Another way of representing it is the fuzzy logic. So what is a fuzzy logic? We will talk about the fuzzy logic in detail also. So fuzzy logic is an approach to reasoning that deals with an approximate rather than the fixed and the exact value. Now here we are talking about the incomplete information or the incomplete data. We are talking about here the approximation. We are not talking about here the exact data. Unlike the traditional binary logic, where we just talk about the exact data, whether the 0 or the 1, the fuzzy logic variable can have a truth values that range between 0 and 1, representing the degree of a truth, right? So something approximation will be done. Now, what are the fuzzy sets and the membership functions? So how you represent the fuzzy sets? What is a fuzzy sets? Fuzzy sets basically allow these are the sets which allow for the representation of a concepts with a huge boundaries. Each element in the fuzzy sets has a membership value indicating its degree of belonging to the set, not exact. So somewhere we are talking about the approximately, it depends or it belongs to a set. Like here we are talking an example here in a temperature control system. Like in a temperature control system, we have taken this example yesterday also. The concept of warm can be represented as a fuzzy sets with the membership function assigning values between 0, not warm, and 1 completely warm to different temperatures, right? What is the fuzzy rules and the inferences? What do you understand by the fuzzy rules and the inferences? Fuzzy rules define the relationships between the fuzzy variables using if-then statements, right? Now here we are talking about the rule-based system where the fuzzy inferences system apply these rules to input data to drive the conclusions based on the conditions and the true value here. So a fuzzy rule for a temperature control system might be if a temperature is high, then reduce the heater power here. So here we are talking about the inference also. Now, in representing a uncertainty in a system, one theory we will talk about in detail is the Dempster-Shafer theory that comes in a syllabus of a third unit. The Dempster-Shafer theory, also known as a evidence theory, is a mathematical framework for modeling the uncertainty without the need for a precise probability. It allows for the combination of evidence. Now here what we are basically collecting the evidence from the different sources to calculate the degree of a belief or the plausibilities for various hypotheses here. So what it allows, at what concept the Dempster-Shafer theory works, it allows for the combination of evidence from the different sources. So whatever the data we are getting from the different sources or the devices, here we are talking about, we will calculate the degree of a belief by checking that data. So in an expert system for the fault diagnosis, right, evidence from a different senses can be combined, right? So using the Dempster-Shaffer theory to access the likelihood of a different fault conditions. Another kind of a theory here we are talking about the Dempster-Shaffer theory, which we will talk about in detail also. Then we are talking about the belief network, which are the extensions of our Bayesian networks only. What do you understand by the Bayesian network? We have already talked about this. So belief networks extend the Bayesian networks by allowing the representation of uncertainty in the strength of dependencies between the variables. How? Because what we do in the Bayesian network, basically we or the system shows the dependencies between the conditional dependencies between the variables. So here what concept it use? It allow or it extend the Bayesian network by allowing for the representation of the uncertainty in the strength wise, right? How much dependency is there between the variables? They provide a way to handle the imprecise and incomplete knowledge. So what are the basically properties of a Bayesian network? If we talk about the Bayesian network, the properties are that it's a, or the characteristics, if we talk about the characteristics are that it is a graphical representation, or we can say that our variables are represented as a node here in a directed acyclic graph and their dependencies are shown as a edges. First property is this, first characteristics is this. Then we are talking about the conditional probability, where each node probability depends upon its parent node expressed, right? So probabilistic model, it built from the various probability distributions of Bayesian network here, applied probability theory for the tasks like the predictions and the anomaly detections here, right? So here we are talking about the various belief networks also, or here we are saying that the Bayesian belief networks are a valuable tool here for understanding and solving the problem. We are talking about here the belief networks. So here we are talking about it is a tool for understanding and solving the problems which involve involving uncertain events, or this is also known as a Bayesian networks also, or decision networks also a decision model we can also say. So here we are taking an example. This provide a way to handle the imprecise and the incomplete knowledge in a AI system. And what is the example here we are talking about? A belief network for an intelligent tutoring system might include notes for student knowledge, engagement, and the performance with the edges representing the uncertain dependencies between these factors. Now, what is the case-based reasoning? We must have talked about this also yesterday. Case-based reasoning is an approach which is also we use for representation of our uncertainty under our AI system. It is an approach where the past cases, right, where the past cases experience are used to solve new problems, and in uncertain domain, the case-based reasoning can be combined with the probabilistic methods to estimate the likelihood of the various outcome based on a similar past cases. Here we are taking an example. A customer support system can use a case-based reasoning to suggest solutions based on a previous similar customer queries, adjusting the recommendations based. So what are the applications of uncertain knowledge representation? First, we are talking about here the medical diagnosis, because in this for diagnosis on particular disease, number of incomplete information can be there, or a noise can be there, or the ambiguity can be there. So how to represent the knowledge under uncertainty or reasoning under uncertainty when, or what is the application here? Here we are talking about the medical diagnosis. Probabilistic model that we are talking about, how we have talked about the probabilistic model. The Bayesian networks are used to diagnose a disease based on the systems and symptoms in the medical history also. What is the autonomous vehicles? Right, so autonomous vehicle is another application here we are talking about with the help of a fuzzy logics and the Markov decision processes, which helps the autonomous vehicle navigate and make decisions in the dynamic environments also. So what is the natural language processing or the NLP? Again, here we are talking about the models and the probabilistic context-free grammars are used for the tasks like the speech recognition and the language modeling. As we have just talked about in an example also. What is a robotistic or the robotics? Excuse me. Robots are use the probabilistic reasoning to handle the sensor noises here and uncertain environments for the navigation and the manipulation task here. Now, what about the finance? Here on the finance, here we are talking about the probabilistic models are employed for the risk assessment, the fraud detection, and the market predictions also. So far, what we have talked about in representing the knowledge under uncertainty is that representing knowledge in uncertainty domain is a fundamental challenge in AI because of our big data, because of a number of formats we are talking about, right? And because of ambiguity of that data, generating of data at a very fast speed. So here uncertain domains are there. So representing a knowledge in an AI system is a challenge in a AI system. So techniques we use here are the probabilistic reasoning, fuzzy logic or the Dempster shuffle theory, bleak networks or the Bayesian networks, and the case-based reasoning also, which provide powerful tools to handle the uncertainty. And these methods enable the to make the informed decisions, adapt to the new information, and perform effectively in the complex real-world environments. So here, by leveraging these techniques, by using these techniques we are talking about, by using these models, AI can better manage the inherent uncertainty present in many applications, leading to more robust and reliable system. Tomorrow lecture, we will talk about different examples also, right?